Hello everyone, welcome to this video. My name is Jhunie L Jumawan.
I'm Dela Peña.
I'm Roselyn N. Calayo.
And I'm Bea Pilar Aguilar. And in this video, we are going to discuss and present our system, which is Facial Emotion Detection System. And without further ado, let's start.
Hello everyone, welcome to our presentation. So in this video, I am going to discuss and show to you our system, which is Facial Emotion Detection System. But before we begin to our proper discussion, let me show you first the sections that covers our presentation. So we have here the first one, which is the introduction, followed by the motivation, the literature survey, statement of the problem, objectives and scopes, modules, which are the training and testing of the system, algorithm use, results and discussion, and after that, we are going to execute and show you the functions of our system. And finally, our conclusion, which is the summary of our presentation. So without further ado, let's start with our first section, which is the introduction. Imagine a world where computers understand our emotion in real time, capturing the intricate dance of facial expressions. Our research takes us on a fascinating journey into real-time emotion detection, combining the magic of convolutional neural networks, or CNNs, the computational muscle of Tensorflow, and the quick eyes of Opencv. In the realm of artificial intelligence, our system is an innovative testament at the intersection of technology and emotion. CNNs, akin to virtuosic instruments, meticulously decipher the intricate language within facial features. TensorFlow orchestrates the computational ballet, refining the model's accuracy for instantaneous emotion recognition. Complementing this, Opencv leads in capturing the visual symphony of expressions, ensuring a seamless real-time fusion of technology and human connection. So our system merges technology and emotion using CNNs to decode facial expressions. TensorFlow refines accuracy, and Opencv captures the visual symphony, connecting technology with human emotion in real time. So at its core, our system goes beyond the basics. It doesn't just recognize smiles and fronts, but aims to grasp the richness of human emotions. Thanks to CNNs, trained on vast datasets using TensorFlow, the system identifies not only primary emotions like happy and anger, but also subtle feelings like surprise and neutrality. Opencv steps in, making sure we see and process these emotions as they happen in real life. So what's special about our system? So our system is not just a tech fit, it's designed to be user-friendly. It understands the natural variations in expressions, making the interpretations of emotions accurate and seamless. So this is a mix of text promises, exciting applications, and how computers understand and respond to our feelings, whether it is in social robots or personalized healthcare. In a nutshell, our system isn't just about recognizing emotions. It's about understanding and responding to the rich tapestry of human feelings in real time, making AI a bit more human and a lot more empathetic. So our system represents a leap toward a future where technology resonates with our emotions. Using advanced deep learning with CNNs, TensorFlow, and Opencv, it interprets facial expressions for applications in learning, companionship, and mental health. So this is the end of our introduction. So now let's proceed to the second section of our presentation, which is the motivation. But before that, I have a question. Ever wish technology could understand your feelings without you saying a word? That's the driving force behind our research. Human emotions expressed through tiny changes in facial expressions hold the potential to transform how we interact with computers, communicate socially, and even receive healthcare. So the motivation of our system is to break free from traditional methods that rely on people telling a computer how they feel, which isn't always accurate. Plus, most systems out there work with static pictures, missing out on the real-time emotions we express every day. So imagine a world where learning apps understand when you're confused or excited, adapting to your mood for a better learning experience. So this means that it enhances our learning experiences. Learning apps adapt to users' emotions, tailoring content and pacing to provide a more effective and personalized learning journey. Robots can be companions, helping out and offering a listening ear by understanding your emotion. So this will build empathetic robot companions. So robots equipped with emotion recognition serve as empathetic companions, offering support and a listening ear based on the user's emotional state. And lastly, the mental health diagnosis becomes quicker and more accurate, improving the lives of many. So this accelerated mental health diagnosis. Emotion recognition speeds up mental health assessment, ensuring quicker and more accurate diagnosis, ultimately improving lives through timely interventions. So our research uses fancy tech terms like CNNs, Tensorflow, and Opencv to make this happen. But the goal is simple: to decode not just obvious emotions like happy or anger, but the subtle ones like surprise and uncertainty. We're on a mission to make a technology empathetic where your face becomes a language that computers can truly understand. So that's the end of our motivation. Thank you for listening.
And now, let's start for our next section of our presentation, which is literature survey. Our journey into real-time emotion detection is informed by pivotal works in this field. Ekman's foundational research in 1972 pioneered facial expression analysis, laying the groundwork for emotion recognition. Liu and Moore review in 2018 highlighted CNN effectiveness in capturing integrate facial features crucial for precise emotion analysis. Acknowledging the significance of extensive datasets, Lucy and Moore in 2010 emphasized their role in training robust emotion recognition models, shaping our research methodology. In the domain of computer vision, Kazemi and Sullivan in 2014 utilized Opencv for facial landmark detection and a vital component in one's emotion classification. Our research builds upon these foundations, introducing innovative methodologies to enhance the accuracy and efficiency of real-time emotion recognition systems. We recognize the collaborative efforts and insights from these influential studies, contributing to the evolution of emotion-aware technologies. And now, let's start for our next section of our presentation, which is the statement of the problem. Our research in real-time reaction detection confronts the specific challenges to enhance precision, adaptability, and the seamless integration of convolutional neural network, which is the CNN, with the TensorFlow and Opencv. Addressing these challenges is crucial for refining our system performance and ensuring its practicality in diverse performance. There are the key challenging in our system emotion detection system. Number one is the limited granularity, which detecting subtle variation with emotions like surprise or fear or impacting precision. Second is the dynamic emotion capture challenge, which struggle to capture the spontaneous and subtle emotions, nuances in real-time interaction requiring improvements. Third is the real-time processing trade-offs, which balancing speed and accuracy in resource-constrained environments poses challenges, necessitating careful optimization. Next is the cultural sensitivity concerns, which potential biases in training data may affect recognition accuracy, particularly for diverse population. In this statement of the problem, we have the research strategies for our system. And the number one is the enhancing granularity. In this, we aim to improve our system's adaptability to discern subtle variation within and between emotions, ensuring a more nuanced emotional spectrum. Second is the optimizing real dynamics. In this, we seek to enhance the system capability to capture spontaneous and subtle emotions, expressions without relying on exaggerated facial cues during interactions. Next is the balancing real-time requirements. In this, we address trade-offs between real-time processing and accuracy to optimize system performance, especially in resource-constrained environments. Second is the ensuring cultural sensitivity. which implementing measures to mitigate biases in training data, enhancing system accuracy and fairness across diverse population. This research focuses on advancing our real-time emotion detection system, capturing a broader emotional range without requiring exaggerated expression and considering cultural sensitivity.
Now let's start with the next section of our presentation, which is the objectives and scopes. Objectives. First, develop a real-time emotion detection system. Create a robust system for real-time emotion recognition from facial expressions in video streams. Second is enhance emotional granularity. Move beyond basic emotions, discriminating subtle nuance within a wide emotional spectrum to enrich the system emotional intelligence. Next is utilize CNNs for feature extraction. Leverage CNNs to extract intricate features from facial images, enhancing the system's capacity for nuanced emotions analysis. Next is train on extensive datasets. Harness the Tensorflow's computational power to train CNNs on large datasets. Enable accurate recognitions of a diverse range of emotions. Next is integrate Opencv for real-time processing. Seamlessly incorporates Opencv for efficient video frame processing and real-time emotion recognition, ensuring optimal performance. Last is ensure user-friendly adaptability. Prioritize a user-friendly experiencing allow the system to adapt naturally to the variability of human expressions for accurate emotions interpretations. This means that the system was designed in such a way to take into account variations in human expressions and provide accurate interpretations regardless of those variations. And now scopes. Focus on facial expressions. Emphasize facial expressions as the primary source of emotional information, excluding other modalities like speech or body language at this stage. Second is a target emotions. Initially, include a broader range than basic emotions, encompassing surprise, disgust, or ambivalence, and other nuanced states with potential expansions in the future. Next is diverse population representation. Train the system on the datasets representing diverse populations to address basis and ensure cultural sensitivity in emotion recognition. Next is the real-time performance. Prioritize real-time performance with low latency requiring specific frame rates and processing requirements. Based on the practical limitations and applications priorities, the system aims to swift and accurate recognition of facial expression, demanding low latency to avoid delays. Researchers are determining frame rates and processing needs for diverse application. This research lays the groundwork for a culturally sensitive real-time facial emotion detection system, offering deeper emotional insights that prior system, its potential applications, span various fields, showcasing promising and advancements. So that's the end of our objectives and scopes.
So for the next section of our presentation is the modules testing and training. First one is to import libraries and datasets. Its main objective is to load necessary libraries and datasets. First step is to import essential libraries such as Matplotlib, NumPy, Pandas, Seaborn, OS, Tensorflow, and CB2. Second is to import Tensorflow Keras libraries. Second is the data preparation. Main objective of it is to load and pre-process the dataset for training. First step is to utilize image data generator for data augmentation and normalization. Second, create data generators for training and validation sets. Third, use flow from directory for loading images and specified parameters. And fourth, enable shuffling for the training sets. For the third one, we have the model architecture. Objective of it is to define and build a CNN-based emotion detection model. First step of it is to build a sequential model in Keras. Second, construct a modified VGG16 inspired architecture with convolutional layers, batch normalization, activization, max pooling, dropout, and fully connected layers. Third is to compile the model using the Adam optimizer and categorical cross-entropy loss. Fourth is our model training. Main objective of it is to train the emotion detection model. First step is to configure callbacks for model checkpointing, early stopping, and learning rate reduction. Second, use fit generator to train the model on the training sets and validate it. Third is to monitor matrix loss and accuracy during training. The fifth one is the model evaluation. Objective of it is to access the trained model's performance. First step is to utilize the model to predict emotions on a test set. Second, evaluate accuracy and loss on training and validation set. And third one is to visualize accuracy and loss over epochs using plots. Sixth is the results and discussion. It presents and analyzes experimental outcomes. First step is to analyze training and validation accuracy or loss plots. Second, discuss model performance, strengths, and areas for improvement. And third one is to relate results to research objectives and broader significance. For the seventh one, we have real-time emotion detection. Main objective of it is to implement the real-time emotion detection. First step is to load the pre-trained model, the classifier, and emotion labels. Second, use Opencv for real-time video capture and face detection. Third, process video frames, predict emotions, and display results in real time. Fourth, allow user termination by pressing Q. 8 is the conclusion. Objective of it is to summarize key findings and draw conclusions. First step is to provide a concise summary of research outcomes. Second, revisit initial objectives and discuss achievements. Third one is to conclude and highlights impact and potential features. And that's the end of the modules testing and training.
Now let's start with the next section of our presentation, which is the algorithm used. First is the model architecture. Our system adopts a modified VGG16-inspired CNN architecture featuring 5 convolutional layers with a batch normalization, rectified linear unit, activation, and max pooling for efficient feature extraction. The system comprises 5 layers into detecting facial features. Eyes, nose using batch normalization for data constancy. Next is the training framework. Tensorflow version 2.7 was utilized within a Python environment, optimizing training with a mix of CPU and GPU resources. The dataset includes 50,000 facial expression, images, and training parameters involve a learning rate of 0.001, a batch size of 32, and 50 training epochs. The training framework utilized TensorFlow 2.7 with a Python, leveraging both CPU and GPU for efficient training. Next is the real-time processing. Opencv integration plays a vital role in real-time video processing, handling frame capture, face detection, and landmark extraction. Model quantization optimizes inference for low latency application. Opencv integration aids real-time video processing by capturing frames, detecting face, and instructing facial landmarks. Next is the emotion detection and display. Predicted emotion are interpreted and displayed in real time using Opencv, ensuring a user-friendly and visually appealing representation directly in the live video feed. This technology can predict how someone is feeling and show it real time using Opencv, which is a software tool for analyzing images and videos. Next is a performance evaluation. Continuous performance monitoring incorporates metrics like accuracy, precision, recall, and F1 score for each emotion category, ensuring the system's reliability and diverse real-time scenarios. In this case, the system is being evaluated based on its ability to correctly identify different emotions. This comprehensive algorithmic framework, tailored for real-time emotion detection, encompasses model architecture, training configurations, real-time processing, and robust performance evaluation metrics. So this is the end of our algorithm use.
So on to the next section of our presentation, which is the results and discussion. In this section, we unveil the findings and insight from experiment evaluating the real-time facial emotion detection system performance. Leveraging convolutional neural networks with TensorFlow and Opencv, the system excels in capturing and interpreting human emotions seamlessly in real-time video streams. model architecture and training, custom CNN architecture, the tailored architecture featuring 5 convolutional layers with batch normalization, real-loop activation, and max pooling, adeptly extract facial features crucial for nuanced emotion recognition. Training process, TensorFlow 2.7 facilitates efficient training with a learning rate of 0.001, a batch size of 32 and over 50 epochs. Augmented dataset enhance the model's adaptability. Real-time processing and optimization. OpenVC integration. Integral to real-time video processing, OpenVC handles frame capture, face detection, and landmark instruction. This preprocessing optimizes frames for swift CNN input, ensuring accurate real-time emotion analysis. Inference optimization. Technique like model quantization fine-tune the CNN for optimized real-time inference, contributing to efficient performance. Emotion detection and display. Real-time interpretation. The system excels in interpreting and displaying emotions in real time, featuring a user-friendly design for clear and visually appealing displays. This enhances accessibility and practicality in various applications. Performance evaluation, continuous monitoring, key metrics including accuracy, precision, recall, and F1 score for each emotion category are rigorously monitored. The system demonstrates reliability and effectiveness in real-time emotion detection scenarios. Implication and relevance. Practical applications. The successful implementation holds promise across domains like human-computer interaction, effective computing, social robotics, and personalized healthcare. User-friendly design. The user-friendly approach, coupled with efficient real-time processing, position the system as a relevant tool in diverse practical applications. Overall summary, the results underscore the successful integration of cutting-edge technologies, showcasing the system prowess in accurately interpreting and displaying emotions in real time. The research implication extend to fostering more empathetic and responsive artificial intelligence system in the dynamic realm of emotion-aware technologies. And that's the end for the results and discussion section.
Hello everyone. In this segment of the video, we are diving into the fascinating world of facial emotion detection. Our system is designed to identify a range of emotions, including angry, fear, happy, neutral, sad, and surprise. Let's run the code and explore how it seamlessly detects and labels emotions in real time. So now let's take a closer look at the code that powers our facial emotion detection system. So as you can see here, we have a set of predefined emotion labels which our system will use to identify and labels the detected emotions. We have here the anger, fear, happy, neutral, sad, and surprise. As we run this code, you'll notice a video stream prompt. So this stream prompts captures faces in real time, and the upper box displays the predicted emotion based on the detected facial expressions. So this part integrates a pre-trained hierarchy classifier for face detection and trained CNN model for emotion classification. So let's run it and witness the magic in action. So as the code runs, observe how it dynamically detects and labels emotions in real time. The upper box here provides instant feedback on the identified emotions. So this system can be a valuable tool in various applications, from user experience research to human-computer interactions. So now, let's put our facial emotion detection system to the test by displaying different emotions. We'll go through angry, fear, happy, neutral, sad, and surprise one by one. Keep a close eye on how the system accurately interprets and labels each emotion. Starting with angry, observe how the system quickly recognizes and labels this intense emotion. The hierarchy classifier identifies the face, and our CNN model predicts the emotion. Moving on to fear, you may notice a subtle distinctions in the system's response. Fear expressions can be nuanced, And this is where the system showcases its ability to capture various emotional intricacies. It's important to note that detecting fear accurately can be challenging due to its nuanced nature. The system, however, does its best to interpret and label this emotion. Let's transition to happy. Watch as the system effortlessly identifies and labels the joyful expression. Happy faces typically exhibit clear features, making them relatively easier to detect. Now, we'll present a neutral expression. This is an interesting test as neutral faces lack strong emotional cues, yet the system excels in providing accurate assessments, showcasing its versatility. Moving to sad, observe how the system captures the subtle cues of sorrow. The CNN model's training allows it to identify even the slightest changes in facial features associated with sadness. Finally, let's wrap up with surprise. This emotion often involves distinctive facial expressions, and the system showcases its proficiency in accurately identifying and labeling these surprising moments. As we've tested each emotion, you've witnessed the robustness of our facial emotion detection system. It's not just about detecting expressions, but also about understanding the subtleties that makes each emotion unique. By pressing the letter Q in our keyboard, this video prompt will automatically exit. Now, I will explain how our system works. So these are the files that we use so that our system works. These files serves different purposes in our system. Like for example, the first one. So this is a Jupyter notebook containing code and documentation for training a convolutional neural network or CNN using Keras for emotion classification. It likely includes the code for loading a dataset, defining and training the model, and evaluating its performance. And this is an XML file contains a pre-trained hierarchy classifier for frontal face detection. It is utilized by Opencv to identify faces in images or video frames. In the context of your system, it is used to detect faces in the webcam feed for subsequent emotion classification. And this is our main code. So this is a Python script likely serve as the main entry point for our real-time emotion detection system. It's used as a pre-trained model, which is the model that H5 and the hierarchy classifier to detect faces in real time using Opencv and predict emotions using the CNN model. And lastly, we have here the model.h5 file. So this is a saved Keras or Tensorflow model file that stores the architecture, weights, and configuration of the trained emotion classification CNN. It is essential for loading the pre-trained model when running the real-time emotion detection system using Opencv. So now I will proceed to our main code to explain how the code works. So this is our main code where we run or execute our output earlier. So the first thing that we do is we import the required libraries. Then we load the pre-trained model and hierarchy classifier. So after that, we define emotion labels, which are the angry, fear, happy, neutral, sad, and surprise. Then we access the computer by using this code. After that, we use this syntax to loop for real-time emotion detection. Then, by using this code, it reads a frame from the webcam. Then, it converts the frame to grayscale for face detection. After that, it detects faces in the frame using hierarchy classifier by using this code. Then, this code will iterate over detected faces. Then, this part of the code will draw a rectangle around the detected faces. After that, this code will extract the region of interest or ROI in grayscale. And this code also will resize the ROI to fit the model input size 48 by 48. And this part of the code will pre-process the ROI for model prediction. Then, by using this code, this will create or make emotion prediction using the loaded model. Then, this part will display the predicted emotion on the frame. Then, this code will display no faces if no faces is detected. Then, this code will display the frame with emotion predictions in real time. And this part of the code will break the loop if Q is pressed, just like what we did earlier by pressing the letter Q in our keyboard. The video prompt automatically exit. And lastly, this code will release the webcam and close all the window. Additional information: the pre-trained model was trained on a dataset achieving an accuracy of 72% in emotion prediction. The higher scale classifier is used for face detection, enhancing the accuracy of emotion prediction by focusing on the detected faces. This code showcases a real-time facial emotion detection system that employs a pre-trained CNN model. The achieved accuracy of 72% indicates the model's capability to recognize emotions in real-world scenarios. So that wraps up the demonstration of our facial emotion detection system. However, our journey isn't complete without delving into the conclusion. Let's dive into the key findings, revisit our objectives, and draw insightful conclusion. Stay tuned for more insights into the culmination of our research. And now finally, the last section of our presentation, which is a conclusion. So this research, or our research, achieved a breakthrough in real-time emotion detection through a specialized CNN architecture inspired by VGG16, trained on 50,000 documented images using Tensorflow 2.7. The model excelled in capturing nuanced facial features. Integrations of Opencv facilitated seamless real-time processing, ensuring swift and accurate emotion analysis. Rigorous evaluation validated the system's reliability and effectiveness. So in essence, this work introduces a pioneering paradigm in real-time emotion detection poised to impact diverse applications such as human-computer interaction and social robotics. The orchestrated symphony of technologies marks a significant stride in the evolution of emotion-aware systems. So that's the end of our presentation. I hope you've gained insights and developed an interest in our system. So thank you very much for listening and watching. Have a good day.